Look up at the sky on a clear night. Not the city sky, the real one. The kind you only see when you're far from everything. Thousands of stars, hundreds of thousands, and behind those, billions more that your eye will never reach. You've seen this before. You know what it is. But there's a feeling that comes with it, quiet and unsettling, that most people push away before they can name it. The universe is too big to be empty. That thought has a way of sitting with you, because mathematically, statistically, logically, it makes no sense that we are the only ones here. The numbers don't support it. The science doesn't support it. And yet, every single time we've pointed our instruments at the sky and listened, there has been nothing. No signal, no response, no sign that anyone, anywhere, has ever tried to reach us. This is the paradox that has quietly disturbed some of the greatest minds in modern science. And the longer we search, the more unsettling the silence becomes. In 1950, a group of physicists were having lunch at Los Alamos. The conversation was light. They were laughing about a cartoon, talking about flying saucers, joking around the way scientists sometimes do when they're not in the lab. And then, one of them, almost offhandedly, said something that stopped the table cold. His name was Enrico Fermi. He was one of the most brilliant physicists of the 20th century. And what he said was simple. Disarmingly simple. Where is everybody? He wasn't being dramatic. He wasn't writing a paper. He was just thinking out loud about something that, once you notice it, you cannot stop noticing. The universe is roughly 14 billion years old. Stars far older than our sun have had billions of years to develop planets, chemistry, life, intelligence. Even if only a tiny fraction of those stars ever produced a civilization capable of space travel, the numbers suggest that by right now, in this moment, the galaxy should be teeming with them. Some of those civilizations should be ancient beyond imagination. Some should have had enough time to colonize entire star systems, to send signals across the cosmos, to leave evidence of their existence scattered across the void. And there is nothing. That question, where is everybody, became one of the most profound unsolved problems in science. It has a name now, the Fermi Paradox. And in the decades since that lunch, no one has found a satisfying answer. To understand why this is so strange, you have to sit with the scale of what we're dealing with. The Milky Way alone contains somewhere between 200 and 400 billion stars. Astronomers now estimate that most of those stars have planets, and of those planets, a significant number likely sit within the zone where liquid water can exist, which, as far as we know, is a prerequisite for life as we understand it. The math, even when you're conservative, produces staggering numbers. Billions of potentially habitable worlds. Billions of years for life to evolve on them. And we have been listening, genuinely listening, with radio telescopes pointed at the sky since the 1960s. We have scanned thousands of stars. We have built instruments of extraordinary sensitivity. We have looked for signals in every frequency we know how to measure. Nothing. Not a whisper. Not a pattern in the noise. Not a single unambiguous transmission from anywhere in the observable universe. Scientists have spent decades constructing possible explanations. Some of them are reassuring. Some of them are not. The most optimistic answer is simply that we haven't looked long enough or hard enough. Space is incomprehensibly vast. Our searches have been, in cosmic terms, extremely limited. We've surveyed a tiny fraction of the stars within a tiny fraction of the galaxy. It's possible, genuinely possible, that signals are passing through us right now, and we simply don't have the technology to recognize them. Maybe we're looking for the wrong kind of transmission. Maybe advanced civilizations communicate in ways we haven't conceived of yet. That's the comfortable interpretation, the one that lets you sleep. But there are other explanations, and some of them are deeply uncomfortable. One of the most discussed is what researchers call the Great Filter. The idea is straightforward, and it is chilling. Somewhere along the path from simple chemistry to a spacefaring civilization, there is a step so difficult, so improbable, that almost nothing ever makes it through. A filter, a barrier that eliminates civilizations before they ever have the chance to make themselves known. The question that keeps scientists up at night is this: is that filter behind us or ahead of us? If it's behind us, if the nearly impossible step was the emergence of life itself, or the development of complex cells, or the evolution of intelligence, then we are extraordinarily lucky. We made it through. And the silence around us is simply the sound of everyone else failing to reach where we already are. But if the filter is ahead of us, that changes everything. It would mean that civilizations regularly reach approximately our level of development and then stop. They collapse, they destroy themselves, they hit some wall that nothing survives. And the silence of the universe isn't evidence of an empty cosmos. It's a graveyard. There is another possibility that sits differently, quieter, more unsettling in a way that's harder to articulate. Some researchers have proposed that the silence isn't absence, it's choice. That civilizations advanced enough to communicate across the stars have, for reasons we don't understand, decided not to. Perhaps they've learned something about the nature of contact that changed their behavior. Perhaps they observed what happened to civilizations that announced themselves. Perhaps the universe has dynamics we haven't grasped yet, and broadcasting your existence is something you only do once. This idea, sometimes called the dark forest hypothesis, suggests that the universe might be full of life and full of silence for the same reason a forest is full of animals you never see. Not because they aren't there, because they know better than to make noise. It's a theory without evidence, but it fits the data perfectly, which is exactly what makes it disturbing. In 1977, something happened that has never been fully explained. A radio telescope in Ohio picked up a signal from the direction of the constellation Sagittarius. It lasted 72 seconds. It was so striking, so different from the background noise of space, that the astronomer reviewing the data circled it and wrote a single word in the margin: wow. That signal, the wow signal, remains the most compelling candidate for an extraterrestrial transmission ever recorded. It matched the profile scientists had theorized an alien broadcast might look like. It came from the right direction. It had the right frequency. It was never detected again. No telescope, at any point in the nearly 5 decades since, has found it a second time. There is no confirmed explanation. It could have been a natural phenomenon we don't understand. It could have been interference. It could have been something else entirely. Or it could have been exactly what it looked like. We don't know. And that uncertainty, that permanent, unresolvable uncertainty, is in some ways more telling than any answer we might have found. What makes the Fermi Paradox so enduring isn't just the science, It's what it asks of us. It holds a mirror up to our assumptions about our own place in things. For most of human history, people have believed, in one form or another, that we are significant, that the cosmos is arranged around us, or at least that we are not irrelevant to it. And then along comes this question, this quiet, devastating question that suggests either we are utterly alone in a universe of 400 billion galaxies, each containing hundreds of billions of stars, or we are not alone, and something has silenced everything else. Neither answer is comforting. We are, at this moment, the only species we know of that has looked up at the stars and asked what might be looking back. That might be the most remarkable thing about us. Not our technology, not our cities, not our history, but that capacity for the question itself. The ability to stare into the dark and wonder. And maybe that's what makes the silence so strange, because the wondering feels so universal, so instinctive, so deeply embedded in what we are, that it's almost impossible to believe we're the only ones who ever felt it. Somewhere in the 14 billion years this universe has been expanding, surely something else has sat beneath a sky full of stars and felt the same pull. Surely something else has built instruments and listened. Surely something else has waited. Or perhaps not. Perhaps the silence is the answer. Perhaps this is what the universe looks like from the inside, when intelligence is rare enough to count on one hand. We're still listening. And every year, the silence gets a little louder.